Hello, welcome to the PTC Virtual Conference. My name is Graham Birch, and the focus of this breakout session is the structured bill of material. Today's manufactured products are complex, and are becoming increasingly complex as products that we once thought of as purely mechanical devices have evolved. In many cases, smart connected products are complex systems of mechanical, electrical, electronic, embedded sensors, onboard software, and even with parts of the product functionality moving off the product and into the cloud. The breadth of digital information required to conceive, design, manufacture, and support such a product is tremendous, and it requires the cooperative creation and management of many artifacts, such as systems of functional designs, 3D designs, 2D drawings, PCB layouts and schematics, software source code, along with additional describing documents and supporting specifications. In addition, in today's globalized economy, this information, the complete product definition, if you would, is created by and must be accessed by distributed teams to enable streamlined collaboration both internally and with external design partners and suppliers. Companies must be able to manage and communicate change across several organizations and roles, and maintain the various configurations required to support multiple activities throughout the value chain. In this presentation, we'll focus on one of the most important deliverables, the bill of material. The bill of material is considered to be the recipe by which a product is made, and as such, it could be regarded as the digital DNA of the product. Errors in this crucial part of the product definition leads to delays, frustration, cost overruns, scrap and rework, and poor quality. And many roles are involved in the creation, editing, and consumption of all this essential product information. If you just consider the design functions alone, there are many teams that will be involved, from mechanical to electrical to software and to quality. And then beyond that, there are many other people who either contribute to or consume the information in the engineering bill of materials. This list can grow, and it includes other teams such as manufacturing, marketing, sourcing, sales, and many others. If you were to map out all of the roles across all the different processes, you'd create quite a matrix of intersection points. Today, many companies struggle with sharing information across these points of intersection due to all the different systems and tools and data types that are used. This creates many challenges, such as manual translation of data, updating of multiple spreadsheets, not knowing which is the latest version, etc. One customer that we spoke to told us they had 29 different spreadsheets across these functions. In the absence of a comprehensive system for the creation and management of the engineering bill of material, companies have adopted several different approaches. Let's take a look at some of them. The traditional approach is to include the bill of material on the engineering drawing. This practice evolved naturally with the evolution of paper drawings, but like many paper-based processes, it comes with some significant limitations. The media on which the BOM is created may have changed from drawing board to CAD, from paper to electronic, but the fundamental process has not changed, and that represents a significant bottleneck. We'll take a closer look at the problems that this creates later in this presentation. Another common practice is to copy and reformat the BOM that is created in engineering into a form and format that's more useful for downstream functions. Often the different formats are sent from person to person via email, resulting in several copies being in circulation. The problems arise when changes need to be made. Now all of those existing BOM documents have to be chased down and updated manually. This is time-consuming and error-prone, and often results in some people working on out-of-date and therefore incorrect information. In many cases, there simply isn't a standard process for creating, updating, and sharing bills of material information within engineering and within the downstream functions. The problem's often compounded when companies have grown through merger or acquisition, and as a consequence use several non-integrated processes, some based on paper, some based on emailed spreadsheets. This all leads to delays in the schedule, decisions being made on incorrect or incomplete information, and Herculean human efforts required to assemble a complete bill of material from several sources. Now let's take a deeper look at just one of these approaches, the drawing-based bill of material process. And we'll ask ourselves, what's the problem? And can the process be improved upon? Here's an example of a typical assembly drawing, where the bill of material table is placed above the legend on the right-hand side of the drawing. This approach is common, and it has some advantages, and it's been used successfully for decades. But there are some inherent flaws with the approach, which result in a lack of the agility that's required to support today's fast-paced product development cycles. If the goal is to manage a bill of material that is complete, accurate, and reliable, then this is not the way to achieve it when speed and scale really matter. When all engineering information is centered on the drawing, the process is a two-stage process. Firstly, there's a composition process in which information such as material specs, critical dimensions, parts lists, etc., are all gathered and arranged on the drawing. All of this information must be defined and complete and then transcribed onto the drawing before the drawing can be released. Secondly, there is the decomposition process, where the consumers of the information must read from the drawing to interpret and extract just the information that's relevant to them. The drawing now becomes a bottleneck, where none of the downstream consumers can receive any information at all until the composition of the entire information set is complete and the drawing is released. This process constriction is exacerbated when any of the information on the drawing changes. If there's a quantity change, the drawing must change. A process change, the drawing must change. Part number change, the drawing must be changed. Replace a part, the drawing must change. Change a fine number, the drawing must change. And so it goes on. Each time the drawing is changed, it's reissued to the downstream functions, who need to determine what's changed and if that change has any impact on them. It's estimated that one change on a drawing may impact 10 times as many downstream activities and deliverables. If, instead of composing all the information onto the drawing and making the drawing the single pipeline of information, let's see what happens when each piece of that same information is managed independently in a part-centric process in Winchell PDM Link. The same information is created in both processes, but we'll see how the part-based approach avoids the bottlenecks associated with the drawing-based approach. In this case, information is composed and released as soon as it makes sense to do so. We don't need, for example, to wait for the material spec to be complete before the BOM is made available. In fact, there's tremendous value in pre-releasing an early bill of material that may just identify the long lead time items so that purchasing can begin their planning process with an understanding that the rest of the bill of material is preliminary. This parallel process allows for greater agility while removing bottlenecks and ultimately faster time to market with fewer errors. Winchell PDM Link provides a part-centric, associative, multi-user bill of material that is a complete definition. We call it an associative BOM because each item on the BOM can be directly linked to all other information such as documentation and CAD models. and it's all managed as a single source of truth. The associative relationships are created as a natural part of the development process and live with the bill of material throughout the life cycle of the product. The bill of material and its related information is updated as a result of further development of our engineering change processes using standardized automated workflows. And it's accessible to downstream consumers to view the information that's relevant to them at just the time they need it. This results in tangible business outcomes for both the designer and the enterprise, where designers can focus on the design and spend less time searching for information. Parts are reused rather than recreated. Processes such as new product introduction, release management, and change management are optimized, automated, repeatable, predictable, and driven by workflow. This results in better revenue prediction with on-schedule releases and better decisions by everyone, because everyone is using the same single source of information, resulting in less frustration for the team, less scrap and rework, and high-quality products. The Winchell bill of material is complete. It's accurate, and it's reliable. Let's take a look at how one of our customers, SRAM, used a part-centric approach to address an otherwise unsurmountable engineering problem. SRAM designs and manufactures high-quality components for the bicycle industry. When a SRAM customer orders one of their components, they need decals and colors specific to their own branding. The old process for such decals was a drawing-centric process. In addition to the decals themselves, there was a drawing with a table that had a row for every decal kit, as well as for every fork drawing, there was information on the decal kit. SRAM would receive many orders from customers for a custom decal. In this drawing-centric process, they had to update and revise the drawings to add the decal kits, and then go through a change process to reissue the drawings, potentially hundreds of times. Each time, users have to wait for the drawings to continue the process. By switching to a part-centric process, they now create parts in Winchell PDM Link to represent the decals, and then relate the Illustrator files to the decal parts. They can then very quickly create new parts and a new bill of material for the decal combination. There's no waiting for drawings to update, and the downstream roles now have rapid access to the correct information without waiting for the re-release of a complex set of drawings. This resulted in reducing the time for custom decals from hours to minutes, and has led to a huge increase in the number of orders that they can process in a year. In fact, an independent study by Nucleus Research showed that SRAM have gained tremendous value from their deployment of Winchell PDM Link with an annual ROI of 128%, 12 months to pay back the initial investment, and a $1.3 million annual benefit. Another great example of a customer that's revolutionized their process around bill of material is iRobot. iRobot are well known for their home use robots. Having a single bill of material that's up to date, accurate, centrally accessible, and one which demonstrates the historical development of its products was critical to iRobot. PTC Winchell houses all of the CAD and the BOM data centrally. It automates change, and it enables collaboration between iRobot and its external vendors and manufacturers, as well as within its internal ECAD and MCAD development teams. Engineers rely on this bill of material and its historical record in order to translate lessons learned and best practices from one product development project to the next. Even non-engineers consistently leverage the rich bill of material data to compare two different products, deliver a quote, or monitor a product's development throughout its completion to delivery. Let's now switch to a demonstration. And let's take a look at what the bill of material experience is like in Windchill PDM Link. In this demonstration, I'll show how Windchill PDM Link from PTC provides a complete view of the design, including mechanical, electrical, software, and related documentation, as seen through the lens of the associative bill of material. We'll use this car as an example, and the first thing you'll notice is that we don't just have a bill of material, but we have a complete, correct, and reliable bill of information. Here we have all of the information associated to the BOM that's used to describe the complete product. Let's take a look at the BOM structure, which, as you can see, includes many types of data. I can select parts from the visualization pane or the structure pane and see the corresponding parts cross-highlighted. Combining BOM and CAD management into Windchill PDM Link allows much of the BOM to be generated automatically from the CAD structure. When I'm investigating an assembly, such as this wheel assembly, it's important that I can quickly view all of the information that describes it. In this case, when I expand the anti-lock braking system, you can see what looks like a traditional bill of material. But when I choose to show all related content, you'll see how that is now a dynamic representation of the bill of material or bill of information, which captures all of the digital content of the product as it evolves. From here, I can view all the different information in the product design, such as electronics, schematics, 3D assemblies, drawings, calculation documents, instructions, test results, ECAD, software, and even the plant from which it's to be manufactured. This allows complete traceability to all of that data as the design matures and moves from concept to release. Because I have all this information related to the BOM, I'm able to take advantage of all of this information directly in our viewing tool, Creo View. Here I can interrogate, mark up, measure, and even perform color-coded query searches on things such as the authoring tool used for the design, or on the life cycle state of the parts, allowing me in this case to visually see any parts in my assembly that are not yet released. I'd like to show you just how easy it is for an authorized user to edit the bill of material directly in the Windchill system. I'm going to add a label to the bill of material. And since the label is an existing standard component, as soon as I begin typing the name, the system searches for and offers me that label as an option. Once the label is added to the bill of material, you can see that the label, as well as any subcomponents to that label, have been added as well. Since I've changed the structure with the addition of the label, I now need to check this in and document the change. It's very easy to send BOM and structure information from Windchill PDM Link to other systems such as ERP. This can either be transmitted automatically or it can be exported manually through the export tool, which supports common formats such as XML, XLS, CSV, and many others. As the design changes over time and parts are added or removed from the design, Windchill PDM Link maintains the change history and provides tools to compare the various versions. The BOM Compare tool allows me to easily compare the latest version of the BOM with earlier versions, or even compare the EBOM with the MBOM or the SBOM. In this case, I'm comparing the latest version with a baseline. As you can see, it's very easy to identify changes that have been made to the brake assembly, both graphically as well as through highlighting in the BOM structure. In summary, PTC Windchill allows you to manage an associative bill of material that is always correct, complete, and reliable, that leads to better decision making by ensuring that everyone has access to the right information, improved process efficiency by removing bottlenecks, fewer errors resulting in costly time delays or scrap and rework. PTC is committed to helping you achieve success. So in addition to outstanding software, Our dedicated customer success team provides a comprehensive portfolio from strategy through deployment, training, support, and success management services. To ensure rapid time to value for our customers, PTC created some value-ready deployments. PTC value-ready deployments are designed to help customers generate return on investment faster and with minimal cost and risk. We offer several VRDs related to the bill of material best practice, including engineering BOM, change management, and data management. To learn more, head over to ptc.com/services/value-ready deployments. I'd like to really thank you for your attention.